balance the following nuclear reactions. So, we're trying to find what our reactant was if it splits apart into boron-tin and a beta particle. I'm going to look at the boron-tin first. So to do our nuclear reactions, we need to know not only the atomic mass, but also the atomic number. So if we go to the periodic table, for boron, we can say that it has an atomic number of 5. So we can fill in the 5. For the beta particle, it has an atomic notation of 0, because while the free electron does have some mass, it's a 1,836th of the mass of a proton, which, for the notation we're using here, is essentially negligible. Now, the atomic number is the number of protons, but being an electron, we have an opposite charge. So instead of having a 1 here, we would use a -1. Now, the numbers on top have to add up to what we started with, and the numbers on the bottom have to add up to what we were starting with as well. So, if we go to the periodic table and look for the element with an atomic number of 4, we would be dealing with beryllium. So this would be beryllium-tin as our final answer. Now, if we do part B, we have nitrogen and carbon. And if we look on the periodic table, nitrogen has an atomic number of 7, carbon has an atomic number of 6. So, 7, 6. So the top numbers are the same, so whatever particle is splitting off has to have a 0 mass, or at least a 0 atomic mass. So we're talking about either a beta particle or positron with that atomic number of with the atomic weight of 0. Now, for the bottom, we have a 7, we have a 6. So for those to add up, this has to be a 1. Well, the -1 was a beta particle. The +1 is going to be a positron, which would be our final answer.